Hello guys. Hello. Hello. Uh, Please, can you guys tell me, am I audible or not? Yes, I will discuss till problem D. Alright, nice. Um, let's start the discussion. So, let me open the power statements. So, in the first problem, we are given an array of size n and n is up to 100. And in each operation, we have to choose two indexes ij such that ai is greater than aj and remove the element j. Okay, so in this problem, if for any element there is a number which is greater than it and its index is less, so if for any index, if all the elements behind it have, if there is at least one element, then we can remove it. So my claim is that you can actually erase all those elements. So let's say this is my array. Okay, and for index I, if there is an element behind it, so it means if there is any element in this part which is greater than this number, then my claim is that we can always remove this number. So we can choose the maximum over here. Okay, we can choose the maximum in this part. So the maximum value, and we can just compare it with the index I. And if the maximum is greater than the value in this position I, then it means we can erase this number. Okay, and if there is no such value, then we can never choose I just such that uh, this is in the index j and we have another I for it, right? So we can actually remove all these values. So like here we can remove 2 and 1 because 3 is before them. And so, and one thing is that the if you remove any index, it does not affect any other indexes. So if let's say someone say, oh yeah, if I remove j and there will be some index k which will be removed by index j, so in that case actually I can use the same I that I use for j to remove the k, because the element on index I was greater than j. So if j removed any of the numbers, I will also remove because I is even more than j. Okay, so now to let's uh, let me. So is this result clear for the first problem? Is the solution for the first problem clear? Uh, so it's really easy to implement it. I'm just showing the implementation of this idea, same idea which I just told you. So you can actually there is an instruction of a wrapper wave which you open when you open a Codeforces problem. So when you click on it, it will open a compiler for you with the sample test cases and the language problem URL. So and you can easily like write your code here. You don't need to copy paste your sample test cases a lot of times. So just get the number of test cases. So we will read the length of the array, and actually we don't have to store the values. So we can just keep track the number of elements we can remove. But and also we need to track the maximum. So all my numbers are positive, so I can initially set this value in equal to 0. And then I will read all the elements one by one, and I will just read the number, and I will just compare it with my maximum. So the the maximum is greater than a, so I can actually remove this number. So I will just increase my count. Otherwise, my maximum is less than equal to, so I can set my maximum equal to a, and in the end I will just output my count. Sound is very loud. Is the implementation clear as well? Yeah, is the I'm Kalim Raza. Should we move on to problem B? Let me go. Okay, let me just. Uh, let's move to the problem B, optimal shifts. Okay, so in the this was problem A. In problem B, so the problem B says that we have given a binary string. So we have a string of ones and zeros, and we have at least one in it. And the operation we can do is like this. So what we can do is we can right shift this binary string, and then on the positions that have one in it. So let's say this was my initial string. So moving it, doing it right shift by one should make this one. So it will remove this one from the last and put it in the start. So this is how we are doing the right shift. So if we do a right shift now, what he is saying, we will take the OR bitwise OR between both those strings. Okay, and what our aim is to achieve all ones in the string. So he initially gave us a one, so the idea is like we have to put on every position at least one time the index with one. So now my first claim for this problem is that we need to do right shifts by one. Like we don't need to do in one move right shift by two or three. So it means like D will be always one. So now let's say do this, if I can take any value other than one for D. So let's say if I take D is equal to 3. So what I can do is I can instead take three, like instead of spending all three at once, I can do three independent queries of one. So I can do this three at different times, and I will still get this at least the same result. So all the ones, because what is gonna happen when if I right shift by one? So all the zeros which are on the right side of one, they are gonna become one. But if I do for d is equal to 3, the ones which are like 3 distance apart from it, they will become one, right? But instead if I do 3 steps with d is equal to 1, so I'm actually converting all of these into one. So, which is, we can see it's clearly better than having a single operation of size 3. So, now the point is how much, we have to, the total number of operations we need to count, like how many operations minimum we need. So, for every zero, we need to have a 1. And we will we are just doing this operation one by one, and each time one of the zeros will become one. So and our string is cyclic, right? So what we are looking for is actually the maximum substring, which is all of zeros, because the one which is behind it, it will first make the first index one, then the second, then the third, and so on. right? This is the optimal way of making all of them one. So the idea will be for each two consecutive ones, we need to count like how many zeros in between them, and we need to take maximum over all the values. So all this is zero. And also an important thing, like if my string is starting with zeros, okay, like say there was some bunch of zeros and then a one, then it was anything, and then in the end I also have some zeros, right? So this whole will be also like considered. So because this is the one which is going to make all these zeros into one. So the length, so the amount, number of coins it will take is actually four. Decrease the volume. Is the volume fine now? Is the solution to problem B is okay or not? How to improve timing? It's actually like a lot of practice. So do some visuals of the same. Take like ABC and do the visual for that. Okay. Now the volume is fine. Nice. So is the solution to the problem B is understood or not? Or there is some part which I should explain? Fine. Okay. Should I implement or is like the implementation is easy for you guys? Yes. So we actually find the gaps between the ones, and we will take the maximum among them. So just to make sure it is cyclic. So the zeros in the last and in the beginning, they all will merge together. Okay, so okay, okay, I am implementing it. So I am just using the repo station here once again. Uh, so okay, uh, okay. Um, so we have first given size and this Now, so what I'm doing is like instead of so I'm keeping the count of consecutive items, and so the idea is if two indexes are the same, so if my string is something like this, so I will make it 1 3 2. So I will instead of keeping the actual values, I'm keeping the count of how many CM elements we have consecutive in a row. Okay, so I'm keeping the count of consecutive in a row. So the count one represents the index zero, and I will start from count index one, and I will just go on. And if um, this one is equal to the element which is on index I minus 1. So if I and I minus 1 are equal, then in this case I need to just increase the count. Okay, and otherwise this means it was not the same as the previous one. So I will now add another element in my into vector with the value 1. Okay, so now what we have is if there were a bunch of zeros in the start, we have a count of them, and then we will have the count of ones, and they both alternate between it. So ones and first it will be the count of ones and zeros based on what my string was, zeros or ones. Okay, so if now we need to actually take the maximum of the gaps. So if my start was if I have zero on my start, so I need to take the index 0, index 2, index 4, so all the even indexes. Let me just make the answer variable, and answer will be the maximum of answer and the CNT. Okay. Otherwise, it will be all the odd indexes because first there will be ones, then zeros, and so zeros will be on index 1, and then again it's the count of ones, and then again zeros. So it will be for all the odds. So now the case which I was saying that this if there are zeros on the start and the end, so they all will combine with each other. So we will just do it like so if the start is zero and so x dot bag actually will give me the last index, the value of the last index. So if both of them are zero, so my answer will be maximum of the current answer and CNT of zero plus the last count, and we will print the answer. Uh, so just tell me if the implementation is clear or not. No, like you can actually do it in that way as well, but you don't actually need it. You can also store one syntax too. Yes, it's like you can store the indexes of all the ones and just find the gap between them. Okay. Is the solution and implementation to problem B is clear? Clear. Okay. Nice. Should we move on to the problem C, or does anyone have any questions? Yeah. Nice. 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 Okay, so let's move on to the problem C now. Okay. So in problem C, we have an empty. So we have a lot of, you can say, denominations. So let's consider it like this. You can consider it. So we have n numbers. So we have a1, a2 till an. Okay, and what we have to do is we have to choose k among them. So for every value from k1 to n, we need to choose k indexes from here. And what we want is that so we have a bag here, and we will put all these elements. So the chosen k elements in the order we choose them. So we will put them into the bag, and every time the sum is even, we will empty our bag. Okay. So if the sum is even, we will empty our bag, and if the sum is odd, we will keep it. And what we want is for each k, we want to find in what is the maximum value we can have in our bag at the end. So after I put all those k elements in the order you have chosen them, I want the value to be the maximum over here. So the first thing we can see is simply if we add, only the evens without any odd number, so we will always have empty bag, because after adding every element, our bag will get empty, and we will have left with zero. So if there is no odd element, so in the first case we have no odd um, no odd ai. So if there is no odd element in my array, so the answer will be all zeros for every value of k, right? And let's say if we have all of my numbers are odd, so what is going to happen? So if I take two odd numbers, whenever in my bag I have two odd numbers, always odd plus odd will become even. So our bag. So in that case, I will have if for all the evens, my answer will be always 0 for all the even values. But for all the odd values of k, I can actually have the maximum odd value over here. So I can actually get the maximum odd value. So I will choose the all the numbers with the maximum, and I will put all rest of the values before I will put the maximum, and in the last I will add maximum into my bag, and this way I will be left only with my maximum, and that is the maximum possible value I can get. So it will be max, and then for 0 it will be uh, for even value of k it will be 0, then it will be again maximum, and again 0, and so on. So it will go like this, right? Now we are up to the case where we have both evens and odds. Okay, so now we are dealing that case. So always, as we want to have a odd element in our array, because if we don't have an odd element, then we will always be getting an even sum, and our bag will always be empty. So we need at least one odd element, and among all the odd elements, which one is the optimal? Obviously the maximum. So out of those k options, so there was k which I want to choose. I have one spot always for the maximum odd, right? So that spot is fixed, and I should always put this number before all the events. So before all the events, and that will be at the end in my bag. I should always put it before them. So once if initially it's odd and I will add all the even values, I will end up always with the odd sum in my bag, right? Okay. So in whatever is in my bag, so the order I will put is I will first put my odd, and then all the even values. Okay. So the number of even values I have. So if the number of even values I have is more than the space which I need to cover, which is k minus 1. So in that case, we can always get the maximum even values, the maximum k minus 1 even values, and we can just add them after adding the maximum odd number. Okay, so we can add the max of the in the after adding the maximum add, we can add the maximum k minus 1 even numbers, right? So now, how we will like find what is the sum of maximum even k minus 1 values? So what we can do is we can first reverse sort all the even values. So we can separate these even and odd values, and then we can reverse sort the even values, and we can actually make a prefix sum, because always what we want is the prefix of these values. So if these are all my even values, so and they are you know reverse sorted. So a of 1, let's name it as e of 1. the first even value, which is greater than or equal to e of 2. Okay, and so on. So we always need a prefix of it because we want to maximize our answer, right? So so just create a prefix sum. So we will just pre-calculate all these values, and what we will do is just take the size k minus 1 and just take the sum from there, right? So this way we can solve for those cases in which the number of events is greater than equal to k minus 1. So all the remaining spots I have elements to fill those spots. But let's say these are my key elements which I want to put in my bag, and this is the spot for the maximum odd. So this is for the max odd. For the max odd, and I have filled all of these values. So all of my even values are here, but still I have if space remaining. What I'm going to do with that space? So in so for those, we need to actually now take the odd numbers because those are the only ones remaining. And for odd numbers, we have already seen if we take two of odd numbers, uh, they will make our bag empty. So after we have taken two odd numbers, our bag will get empty, right? So what we will do is here remaining area which we have. So if this is even, then we can actually first choose those odd numbers into my bag, and those will use up the space. And after that we can again do the same idea, put the maximum odd and then all the evens, right? But if this space is odd, in that case, actually we need one space from here, from this which we have already kind of pre-booked. So we need to take back one place from here. So but what will happen with that? We will place one of the remaining odds, and now we will again have even odds, and it will remove all of this, and we will just remove the smallest even number from my sum. So this way we have covered all of my operations, and we will end up with the maximum sum because we cannot take another even number to make this space, or we can so if the remaining space is odd, so we have to give away one of our remaining used space for the even numbers to give it to one of the odd numbers, so that they will cancel out with each other, and we don't have to we have the maximum possible positions that we can use in order to maximize our sum. Is the solution to the problem C is clear? if you guys understood the solution quota plus, otherwise just tell me which part you haven't understood, or I should repeat, or should we implement it? Is the solution to everyone is clear? Okay, let's implement its solution. So, okay, so let's just read the test cases. Okay, so now we have n and we are given the array. So which is n, which is read n, and let's create an array of n. Okay, and now instead, like, I think it's better to separate both of them initially because we want to deal with odd and even separately, kind of. So let's just have them both in a separate arrays or vectors for use. Okay, so let's make a vector for even and odd, and I will just go through. So I will just read my element, and if even, I will just put it in the even vector. So now let's do all these cases which I have written now. So if we have no odd numbers, it means all the answers are zeros. So if odd is empty, so in this case we need to just print all of the zeros. So okay, so this was our case one. Now in our case two, so what we have is for all the odd values of k, it will be the maximum. But for all the even values of k, it will be 0. So if even dot empty, so if this is empty, then we have, so if k mod 2 is equal to 0, in this case my output is just 0. If k is odd, then I need to put the maximum. So for that, I will just first, reverse sort both of them. So the maximum will be on the first index and the minimum will be on the last index. So I will just reverse sort both of them. And now here I just need to print the first element, which is the maximum. Right? And that's it. So now we have covered both of these first two cases. Now we are in the case in which we have both odd and even. So now we are in the third case. So the first thing we want to consider is if the remaining space is actually less than equal to the number of evens. Because for all these values we can take the prefix and we can just fill it out, right? So now let's just iPhone. Okay. So if the given size is less than is greater than equal to k minus 1, so in this case what we can do is actually cover all the positions, right? So now let's just make a prefix sum for our if. So prefix of I actually tells the sum of first I values. So the sum of first zero values is just 0, and now we will calculate for, so uh, prefix of I plus 1 will be just prefix of I plus even of I, right? And now in this case where we have our space which we have is enough, so we can cover all of them with evens. So in this case, the answer will be just the maximum odd number, which is odd of 0 plus prefix of k minus 1. So now here is we are in this case. So now the space which we have, like the number of operations which we want to do, is much more is more than the number of even plus one odd. So we have some more operations to do than we, so in this case we need to include the odds, pairs of odds. So the pairs of odds will cancel each other here. Now we need to look for the size of it. So we are actually concerned with the parity of this remaining size. So if it's even, my answer is just the maximum plus the sum of all the even numbers. Otherwise, I have to remove the smallest uh, even number in order since I want to maximize my sum. So here, what I will do is if k minus 1, so 1 is for the odd, the maximum odd I have chosen, and then all of the size. If it's odd, so here in this case I need to output, the odd number plus prefix of. So we need to just remove one of those numbers, and else in the other scenario we will just take the maximum odd and we will add uh, even dot size. And in the last we will just see out and yeah, one important thing which we should also take care in the problem C is, let's say, this is just a corner case. So for k is equal to n, so if my k is n and the number of odds are even, so the size of odd numbers is even actually. So then in that case I will have 0. So this is one of the case which is missing right now. So what we will do is let's just add it. Let's see here. So if k is equal to n and then our dot size, and this is even, then out 0. Continue. Okay. So yeah, now the implementation is correct. So what we do is first separate both the even and odd, and then I just sort both of them in descending order, and then I just check for the, if any one of these are empty, so I can easily answer those cases. And now I just keep a prefix and you can also like make a variable and just increment it, but here at this way you have to take care like when you have to add and when you don't. So I feel like this is a more neat way to do this. So just pre-compute it and here just tell you want to take the sum of the first k minus 1 numbers, the maximum k minus 1 evens. So and here this is just a corner case. So if like if all the number of odds are even and k is n, so in that case we know all of them will be paired with each other and they all will be get out. and all the events they will all get out. So the remaining will be the zero. In all the other cases, we will just check if we have if the number of events is greater than what I need to do, then I will just take the maximum k minus one and one of the odds. Otherwise, I will just check the size of the remaining part, and if it's even, I just take all. So I will first add the pairs of the odd, and they will all cancel out with each other, and then I will just take the maximum odd and all the evens. Otherwise, so if the size is even, otherwise I just borrow one space from the evens. So I need to remove one of the evens, and in place I will put one of the odds. So you can copy your code from the solution and explain it with comments. Uh, I just now it's implemented. So is the solution implementation clear? Yes, I will discuss the solution to the D. Let me, if is the system testing is over or not. Can I submit my solution to D? Let's see if the solution get accepted or not. Uh, so yes, this is my first time, so might be I will get better with your feedbacks. Uh, I was in the problem D. I was trying to get it, but I was like having a time limit exceeded on test case 22. So the idea which I have is correct, but I was a bit, I have to a little bit optimize it. Yeah, so I have 6 as well, but I have like 19, 22. I have time limit set on there as well. So, uh, first of all, now let's discuss like what we can do for problem D. Might be like we need to do a little bit optimizations to the solution of D, but like there's like some ideas which I haven't tried yet. So let's see where we can get from it. So first of all, that first fact which I want to tell you guys is what will be the maximum length of my path. So in problem D, so the first thing I want to focus on is the maximum length. So the maximum length of my path, which is Fibonacci. So it this the index of the first Fibonacci. Um, and so what would you suggest in improving the speed in contest and improvement? So just to virtual contests, they help a lot. So just make a virtual of to 4 to 5 problems, or might be 6, 7, and do it in 2 hours. Um, the problems in the about the range of your rating plus 200, something like that, between your rating and max rating and the 200. Okay, so that will help you a lot. Or just take the problems which you are stuck in, like the ABC. So just take 2, 3 contests, add their ABC problems, and do it in 2 hours. So practice is the key. Okay. So what now here want to know the maximum length. Let's back to the problem. So we want to actually get the maximum length of my path that can be. So the 88th Fibonacci number. So you can just Google search it. The 88th Fibonacci number. It is actually larger than 10 raised to the power 18. So it is greater than uh, 10 raised to power 18. So my maximum path length is going to be 88. Right, 88 edges, right? So because otherwise the number should be in Fibonacci we have the minimum starting values. So this way, if we have any other values, the length will be even much less than 88. So we have a maximum path length of 88. Now, what I want you to consider is uh, to form some sort of a DP, which we can work with. So what I have the idea was to have a DP of V, where V is the last vertex I have. So I'm just starting with the very beginning of my idea. So DP of V, which was the last vertex on my path, and U will be the second last vertex on my path. Okay, and we have this size, which is telling the size of this path. Okay, so what this TP have is the count of the passage that it ends on the edge UV, and the total path, the edges in this path is size. So this is size is the number of edges, not the number of vertices. It's the number of edges, right? So now initially, what we can do for each edge, we can just say so for each edge UV, we can actually use DP of V to show of 1 is 1 because every size 2 is a Fibonacci sequence. So we will just have it. And now when we want to update, so from UV, so what we want, some other vertex W, so AW should be AU plus AV. So the value on it should be the sum of these two values. So we can actually search in the uh, we can search in V's, all the edges of V's, and we can just find if that is satisfying this condition. If yes, we just update it. Otherwise, we just leave it. Okay, but the time complexity this way will be very insane. So this is something like we have size, and our size is around log of the values. So you can say it's constant. It's something or log a, where a is the maximum value. Okay. So right now our time complexity is, so for each edge we are so in how many states we have? We have, for each edge we have a state, right? So the number of states is, the number of edges we have is m, and for each edge we can have like any one of those size. So we will have m into log a times, and the maximum value of the degree of vertex can be n. So we have some time complexity like this, which is obviously not gonna pass, right? So now what I did was a little change to the definition. Okay, so I just changed a little bit of mistakes. So the point is that u does not matter. So the value of u, it doesn't really matter. So what matters is the value a u. So the value which is assigned, so the a value of vertex u, right? Because there can be many different vertex with the same value, right? So all of them will be making forward go. You can make widget contest on Codeforces. Use mashups. Okay, so go to the gym and you will find the mashup option. Okay, so are you guys with me till now? Yes. Okay. So now what I did was, because if I analyze the vertex V is the last vertex on my path. Okay, so there can be, for a single vertex W, there actually can be many values that satisfy here. So there can be many values for U if all of them can have the same AU value. So it's actually better, instead of keeping the exact value of U, I just keep the AU value. So all those options will be merged together. So right now we have like three different ways of coming to the V and then go to the W. So I just instead of going each one of them one by one, we can actually go all of them at once. So now what I define my tip is like, here is the value of the second last. Okay, so it is the value instead of the node itself, and then I have this size. Okay, so now what? So if we use the Fibonacci equation, so what we can do is we can go through. So for size, so we can go from size 1 till 88, and here is we can go on all the edges, right? So for all the edges, V comma W. So the edge goes from V to W. We have directed edges. So what will be the change for you know TP of W, and the second last value on this path will be AV, right? And the size will be the current size plus 1, and this TP will be increased by, so this TP will be increased by, so the last vertex till now we have is V, and what will be the value over here? So we know AW should be equal to AV plus AU. So but here we want to find the value of AU. So we actually want to find the value of AU. So we just make AU the subject. So AU will be AW minus AV. So here we can find AU and our current size. Okay. So now this is will be my DP, um, and we just want to do this. So now the time complexity over here is, first of all, we have a log a factor because of the size, and then we have this loop on the edges which is of size m, and we're doing just one operation in each one of them. But the point is, we cannot create such big values as in my DP state. So these two values are small values. So we can actually make an array of size n into a current. So we can actually make sections. But this values, this can be like up to 10 raised to the power 18. We need to use some data structure like map or something like that. So that will take log and log and factor as well. So right now our time complexity is m log n times log n. Okay, so but the problem is this will also give you the integral. So this was actually my solution for this problem D, and I thought it would work, but we need to do some optimization. Might be get rid of this log n, or might be this log a. Yes, it's a pain if you have m log and times log estimation. So is this solution clear? Although like it will be TLE, but it's good still. Yes. Okay. Yeah. So this was all like which I can tell. Okay. If anyone have any questions, please ask me. Otherwise, the stream will be over. Okay. It seems like we don't have any questions. So yeah. Goodbye. Have fun. Wait for the rating changes. Okay. Goodbye.